Hi everyone, today I will present my project, ChatGPT-on-Phone. The only team member is Dinglan Pen, who is myself. First, let's start from the overview of this project. This project implements an Android mobile app that works as a speech chatting robot, which means the user uses human speeches to tell the robot, and the robot responses also with human speeches. It uses the server and client design. The server connects to the OpenAI API for speech recognition, text generation, and text-to-speech. And then the client runs on the phone, communicating with the server to send and receive audio. Now let's introduce how the server works. The server uses Node.js, which has official API support from OpenAI. We use Express, which is a famous framework for Node.js to implement HTTP APIs, to implement an HTTP API for our service. It implements three services. The first one is speech recognition at the path SR, and the service of text chatting at the path chat, and finally the service of text-to-speech at the path TTS. The server serves as a remote VPS server protected behind Cloudflare CDN to prevent from any attacks or including DDoS attacks. Now let's first start from our first service from the server, the speech recognition service. The speech recognition service uses OpenAI's Whisper model. It firstly gets the input from the form data of the HTTP post method sent by the client. Then it saves the input into a temporary file and uploads it to the OpenAI API to recognize the speech and convert it to a transcription of text. Finally, it returns the recognized text to the client. It receives the OGG format because the browser uses it as a normal format for record. The second service is text chatting. It is used to interact with the bot in forms of text. The text chatting service uses session, which means it saves the history of the same client, including the input and output for each round. Then, with saved history and the current input, the service sends a request to the OpenAI API using the GPT 3.5 model, and it gets the output from the OpenAI API, followed by sending it back to the client. The last service is text-to-speech. It is used to get a text response from the robot to human speeches. The service receives text from the client, invokes OpenAI's text-to-speech API, and returns the audio file retrieved from OpenAI to the client. Then the client can use the received MP3 format to play it back in the browser or the application. Now let's discuss how we design the client. We first write the client with HTML plus CSS plus JavaScript, just as a web application. Then we use the popular web view in Android to wrap the web application as a mobile application. Now let's first talk about how we design this web application. We uses a UI of a single button for operation. it initially says click to record. After clicking it, it starts recording. And if you click it again, it will send the recorded audio to the server, gets the recognized text, and then it sends the text to the server to get a response using the text chatting API. Finally, it uses the response text to the server to generate an audio of human speeches. Finally, it plays it, and the user is able to stop it at any time and returns to the initial state. Then we wrap it to an APK package. We use the WebView API to load the remote web application as a mobile app. It is based on the project on GitHub. Also, we need to request several Android permissions to access the microphone, including the internet for web browsing, record audio, microphone, and modify audio settings for recording audio. Finally, we also need to grant permissions to the WebView instances because JavaScript has its own permission system. Now let's talk about the performance. We measure the latency both from the client side and the server side to understand what the bottleneck is. Firstly, let's show the latency from the client side. We collect the time difference between sending audio and receiving audio. We notice that the mean latency is 269.94 milliseconds, while the median is 2610 milliseconds. We first try to have a so-called optimization. We tried to directly use the audio to the server and receives the audio without 3 requests and only have 1. However, the result shows that there is no significant difference between these two approaches. So our optimization is that this specific optimization doesn't work. Later, we measure the latency from the server side to see how much OpenAI API contributes to the latency. It shows that it's about 280 milliseconds less than the client-side latency the It shows that most of the overhead comes from the connection between our server and the OpenAI server. Is there any possible optimizations to improve its performance? We propose the two. The first one is to use OpenAI's Stream API to achieve pipelining to reduce latency. And the second thing is that we may use better audio compression than OGG to make the most use of the bandwidth, and it can possibly reduce the overhead. So, in conclusion, firstly, we implemented a speech robot for web and Android. Then, it is built on the standard network protocols based on our client and the server design. Finally, performance evaluation shows that the performance bottleneck is between our server and the OpenAI server.